Ever wondered what's really going on inside your banking app? Behind every tap and every swipe? Well, it's not magic. It's actually an invisible blueprint, a superstructured system that keeps track of every single cent. Today, we're going to pull back the curtain and see exactly how that blueprint works. All right, let's get into it.
Really think about it for a second. You hit send on your phone and boom, the money just goes. It feels instant, right? But behind that one simple action is this incredibly complex, perfectly organized system that has to get everything right 100% of the time. So what on earth is that system?
Well, it all boils down to something called a database schema. The easiest way to think about it is as the bank's master blueprint. It's the whole set of rules and connections that make sure every dollar is accounted for and every transaction is secure. This isn't just about code. This is literally the architecture of financial trust.
To really get our heads around this blueprint, we're going to do something cool. We're going to build our own virtual bank right from scratch. And we're going to start with the two things you absolutely can't do without: the people and, of course, their money.
Okay, first things first. Piece number one of our foundation is the customers table. This is basically where the bank remembers you, your name, your unique ID, all that stuff. Now check this out. See that little unique tag on the email column? That's a super simple rule, but it's a critical first line of defense. It makes it impossible for two different people to sign up with the same email. Simple, but effective. All right, next up, we need a place to actually keep the money. And for that, we have the accounts table. Every row here is a different bank account. And notice the data type for the balance, decimal 15,2. Now that might look like a boring technical detail, but it's the bank's promise of precision. It guarantees that every transaction is tracked perfectly, right down to the last cent. This prevents those tiny little rounding errors that could cause massive, massive problems when you're dealing with millions of transactions. So we have a table for customers and a table for accounts. How does the bank know which one belongs to who? Well, that's where this crucial little thing called a foreign key comes in. It's basically the digital glue. It creates a secure, unbreakable link that connects the customers table to the accounts table, tying your profile directly to your money.
Okay, with customers and accounts linked up, we need to track the actual movement of money. That's the job of the transactions table. You can think of it as the bank's digital ledger. Every single time money moves, whether it's a credit coming in or a debit going out, a new line gets written here. It's the permanent, unchangeable history of everything that happens.
So get this, with just these three simple tables, our blueprint can already answer some pretty powerful questions. Like, how does your banking app instantly tell you your total balance across all your accounts, checking, savings, the whole shebang? It uses a query that looks something like this. Now, don't let the code freak you out. It's actually really straightforward. The select sum part just tells it to add up all the balances. The from and join parts use that digital glue to link the customers and accounts tables together. And the where clause zeroes in on you specifically, using your email. It's simple, it's powerful, and it's lightning fast.
And just like that, boom, we've built the core of our bank. We've got the who with our customers, the what with the accounts, and the how with the transactions. But a real bank is a lot more than just a ledger. So let's see how this solid foundation lets us grow.
Right, so a real bank doesn't just hold money, it offers services. So let's expand our blueprint and add some new features, like loans for people who need to borrow and physical branches for when you need to talk to a person.
The beautiful part about a well-designed blueprint is that adding new services is pretty straightforward. You just add new tables. A loans table can track how much was borrowed, the interest rate, and when it's due. A branches table can manage all the physical locations. Each new piece just plugs right into the core system we already built, letting the bank's capabilities scale up.
And with this new information, the bank can start answering more complex business questions. For example, from a risk perspective, they might really need to know, who are our biggest borrowers right now?
And once again, a simple query gives them the answer. This time, the where clause is the real hero. It acts like a filter, scanning through all the customer and loan data to find only the people who meet two specific conditions. Their loan is for more than 50 grand, and its status is active. It's a perfect example of how this blueprint turns raw data into actual business intelligence.
But, and this is a really big but, as this system gets more complex, the risks get bigger too. As our blueprint grows, so does the potential for mistakes, for errors, and for fraud. The system is more powerful, yeah, but it's also way more vulnerable. And that is why the most advanced, most important part of the blueprint isn't about adding cool new features.
It's about adding layers of protection. It's time to stop being an architect and start being a security guard. We need to build a digital fortress around our data. So meet the bank's unseen security camera, the audit logs table. Anytime a sensitive piece of data gets changed, like someone's account balance, this table records everything. What was changed, the old value, the new value, and exactly who changed it. For security and for legal compliance, this log is the bank's ultimate source of truth.
And if the audit log is the security camera, then this is the system's intelligent tripwire. The fraud alerts table is where the bank's automated systems flag anything that looks suspicious. If a transaction gets a high-risk score, it gets logged here instantly with a reason, like high velocity, so a human investigator can jump on it immediately. Okay, so we've built all these pieces, the foundation, the services, the security. Why does any of this really matter? Well, let's see how this entire complex blueprint comes together to solve a very real and very modern problem.
Let's talk about something called velocity fraud. This is a classic scam. A criminal gets a hold of someone's account info and tries to drain it by making a ton of small transactions really fast, hoping they'll fly under the radar. So how can our blueprint possibly detect this in real time? This is where the blueprint really earns its keep. This advanced query is like a brilliant detective. By joining the transactions table to itself, it can compare every single transaction against all the other transactions from the same account. The really clever bit is the where clause, which looks for another transaction that happened within a 5-minute window. It's an incredibly smart way to spot those rapid-fire patterns that a human would totally miss, triggering an alert automatically.
So let's just recap the journey we took here. We started with a simple, solid foundation of people and money. Then we expanded it, adding new services and locations. And finally, we wrapped the entire thing in a fortress of security and auditing. Each layer builds on the last one, creating this invisible, intricate, and absolutely essential foundation of our trust in digital banking.
This blueprint is really solid for the way banking works today. But as finance gets even faster, with things like instant payments and AI making decisions in milliseconds, what new rules and new layers will the blueprint of tomorrow need? Well, that's the big question for the future of finance.